Check one. 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 Right. Good evening, everybody. Back again to the online session. Today is actually a extra class for our online students. And because for the online interactive students, last month I had to cancel a class. In the today is an extra class. Today and tomorrow, both the days extra class, right? As I told, it's a open link class. Anyone can join. We are going to finish off power and energy lesson. Not just going to start it and stop it in the middle. Today and tomorrow, both the days we are doing to finish off that full lesson, power and energy lesson, power and energy of electrical appliances, right? So this is for the online kids. Physical students, how join window. I told Kotaina people physical doesn't need to join. Candy physical doesn't need to join. Golf physical doesn't need to join. Vattala physical has to join because tomorrow is Vattala class day. Tomorrow we are not doing any classes, any physical classes. So tomorrow Vattala physical should to this class. So Vattala physical students and for online students. And open link, anyone who wanted to cover up this lesson can join. YouTube video will remain until the end, so you can watch that also. Hurry. Without any further delay, let's start the section. But before we start, I will allow you all to unmute. Just confirm me whether the video, audio, everything clear from your end.
Perfect.
Yes, sir, all
Yes,
clear.
sir. Yes, sir, all clear.
Yes, yes.
Hurry. Hurry. Nothing to wait. We'll start the lesson. Hurry. We'll start the lesson. Lesson for grade 11s, power and energy of electric appliances. Power and energy of electric appliances. Unit number 10. Power and energy of electric appliances, unit 10. Simply, what you learn in this lesson. Now, heading is telling. We learn about power and energy. Anisa, we already learned about power and energy. No? Yes, Puta, you learned it in grade 10. There you generally learned about mechanical power and mechanical energy. Now we are a bit deeper. We are going to learn about power and energy specifically in what? Electric appliances. So we are going to discuss about power and energy in electric appliances. That is the base of this lesson. Okay, hurry. So we'll start first going to power. ඒකටත් කලින් චූටි part is there. Even before that, another small part is there. First of all, tell me, lamai, what is an electric appliance? What's an electric appliance? What is an electric appliance? Tell me first of all, what is the energy we give to an electric appliance?
Electric energy.
Electric energy. So using that electric energy, what does that appliance do? It makes our work harder or easier. What does it do?
Makes work
Make the work easier. So what's the electric appliance? An appliance that makes the work easy by taking electric energy. It makes our work easy by taking electric energy. That's an electric appliance. You all tell me some electric appliances in your house. Tell me some, wait a minute, tell me some electric appliance in your house. Tell.
Fan,
Fan. What else?
refrigerator, TV,
Iron.
washing machine,
Came. I'll write iron. Electric iron.
electric kettle,
Electric iron. Someone told television. Sorry.
Radio.
radio,
Radio. Perfect. What else?
light,
Light
Torch.
කියන්නේ ළමයි
Torch.
bulb නේද?
Torch.
Bulb. About 5 are there. So these are some electric appliances in your houses. Very good. Phone, laptop. Right. I need about 5. Fan, electric iron, radio, bulb, television. Right. What is the energy conversion? What is the energy conversion taking place in these electric appliances? Y'all tell me. Fan, what we give as the input energy?
Electric energy.
Electric energy.
Electric energy.
Electric energy. Now this is grade 6 work, energy conversion. That is converted to what energy in a fan?
Kinetic energy.
Kinetic energy. Some people will tell wind energy. Now think a little bit deeper. What is wind? Moving of particles. Air particles moving from one place to another is wind. Air particles moving. Particles are moving. If particles are moving, what energy is there?
Kinetic energy.
Kinetic energy. So wind energy, the base in the wind energy is kinetic energy. Even though we define separately as wind energy, in the base level, wind energy is kinetic energy. Particles are moving. Air particles are moving. So instead of telling wind energy, you can perfectly tell it as kinetic energy. Kinetic energy. All the others, your work. Grade 6, this grade 6 work. Take out the tube. Take out the tube. First page. Power and energy of electric appliances. We use different electric appliances to do various jobs in our daily life. Electric energy is converted to some other form of energy in electric appliances. Under that, a table is given. I want you all to write these electric appliances and write the energy conversion. Zingala do it, zingala do. Tin 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 gala do. So can we say mechanical energy? Mechanical energy is both kinetic and potential. So in wind, there is no potential. So better to tell kinetic. Will always the input energy be as electrical energy? I don't know. You have to find it.
அடி இப்ப ஜாயின் ஆயினே என்ன அன்மியூட் பண்ண
Quickly work. Once done, tell me done. 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 Perfect. Huh. Electric iron. What does electric iron do? It will convert, there you go, electric energy into what? Heat energy. Electric energy, there you go. Heat energy. Radio. Radio input is electric. Electric energy into sound energy. Into, there you go, sound energy. Bulb. Bulb, there you go, electric energy into light energy. Finally, television. Television. Input is no doubt electric energy. What's the output? What you get from a television? You can see something. Light energy is there. Is that all? No. You can hear. You can hear. Sound energy is also there. Light energy and sound energy together. Light energy and sound energy together. That is television. Grade 6 work, eh? Some people asking, sir, behind the TV, heat is generated. Can't write heat. You can write heat, but here what I wanted you all to write is the expected energy. What we expect from a fan is kinetic. What we expect from iron is heat energy. What we expect from radio, sound energy. What we expect from bulb, light energy. What we expect from television, light and sound. So write only the expected energy. I'll teach about that heat generation separately. Only the expected form of energy, right? What we expect from these electric appliances. Okay, simple section. Right. Now we can go to the lesson. Now we can go to the lesson. Power and energy of electric appliances. You know about electric appliance. Now go into this power section. Now go into the power section. Simple sections. Don't keep these lessons to study on the day before the exam. Now when I'm teaching, it's a focus and listen, these 2 hours, whatever I tell should go inside your eyes, should go to the brain and get stored. You should feel that. You should have that feeling. Otherwise, don't sit here. In vain, you are wasting 2 hours. Instead of that, you can watch a movie now. At least that movie will go to your mind. So whatever I am telling now, it should go inside your eyes. It should go to the brain. It should get stored. You should have that feeling each and every second. Whatever I am telling, if you follow me properly, surely you can have that feeling. If you have that feeling, this can be erased from this brain. That is how you study. You don't need to sit separately to study these lessons. There are lessons where you need to sit and separately put extra effort, like electrochemistry hammer. One time when we do in the class, it's not that much clear. You have to go home and write those reactions again. You have to revise it again. But this lesson not like that. While I am teaching, you can record it to the mind and store it. Such a lesson. Annivaring, surely you have marks question for the exam. That means marks for the exam. A section you can learn while I'm teaching, a section where you have marks. Why wasting time then? While I'm teaching itself, record it to the mind. You're finishing off this lesson today and tomorrow. Today and tomorrow, these 2 hours, tomorrow 2 hours, 4 hours, this lesson is done. After that, no touching this lesson until your exam. That way you learn it. Hurry. Listen, now whatever we did until now are grade 6 things. Now the main section, right? First going to power. Anis, we learnt about power, no? Yes, we learnt about power. Where? In grade 10. But in grade 10, you learnt about mechanical power. Power, energy, or kinetic energy, potential energy, half into half mv squared kinetic energy, mgh, potential energy. That is mechanical power and energy. Now we are going to specifically learn about power of a electric appliance. Simple question. Tell me what is mechanical power? Grade 10 you learnt about power. No? Tell me the definition of power from that knowledge. Anyone can remember. Now don't turn the, you should turn your brain and tell what is power? Mechanical power. Don't think about electric appliance. What is mechanical power? Grade 10 work.
Work done in a unit period of time.
Perfect. Work done in a unit time is power. Did you learn it? Grade 10. Work done in a unit time is power. Here also, definition is all same, but only one thing get added. See, what is power of an electric appliance? Work done in a time in an electric appliance. That is power of an electric appliance. Make sense, no? What is power of an electric appliance? Work done in a unit time in an electric appliance. Repeat with me. What is power of an electric appliance? Open the mouth and repeat with me. Work done in a unit time in an electric appliance. Once more. Work done in a unit time in an electric appliance is power of a electric appliance. I'll go one more step ahead. Tell me, Lamai, what's the unit of work done? Anybody who knows the unit of work done?
Joules.
Perfect. Unit of work done is joules. Unit of work done is joules. Question. Tell me another physical quantity that has the unit joules. Another physical quantity with the unit joules.
Kinetic energy.
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 Energy. Kinetic energy, kinetic energy, potential energy, heat energy, any energy. For energy also, unit is what? Joules. Now see, work done is measured in joules. Energy is also measured in joules. Then I can tell work done is energy. Energy is work done. Correct? No? Why? Work, the unit is joules. Energy, the unit is joules. If two physical quantity have the same unit, then those two physical quantities should tell the same thing. Work done is measured in joules. Energy is measured in joules. That means work done is energy. Energy is work done. Both have the same unit. So putting that to our definition, I can remake the definition of power. What is power? Now see. What is power? Energy consumed in a unit time in an electric appliance is power. Before, what was the definition I told? Work done in a unit time in an electric appliance. Now, energy consumed in a unit time in a electric appliance. So, two definitions for power of electric appliance. What are the two definitions? Work done in a unit time in an electric appliance is power, or energy consumed in a unit time in an electric appliance is power. Repeat with me. What are the two definitions for power of electric appliance? Repeat. Open the mouth and tell. Work done in a unit time in an electric appliance, or energy consumed in a unit time in an electric appliance. Okay. Go to the tute. Power output of an electric appliance. What is power of an electric appliance? Under that, we'll write the definition. Use a color pen, nicely write down. Notes lamai nicely write down. Then only you will get the feeling of studying that. Don't write. Even if you don't have the tute, let's say you are writing in a separate book, nicely write down power. Quickly write down the heading power. Under that, write down. What's the definition? Work done in a unit time. Work done in a unit time. Work done in a unit time in a electric appliance. In a electric appliance. In a electric appliance. Or energy consumed in a unit time in a electric appliance. In a electric appliance. Again, I'll repeat both the definition. See whether you have written it correctly. Work done in a unit time in an electric appliance, or energy consumed in a unit time in an electric appliance. Is power. Write it like that. Is power. Is power. Right. Eyes on the board, ears on the speaker. Listen very carefully. How to calculate power in an electric appliance? Simple. We have an equation. Power of an electric appliance is equal to voltage multiplied by current. Voltage into current gives us the power of electric appliance. If I write it symbolically, power, the symbol is P, voltage, capital V, current lamai, what's the symbol of current?
I.
I. Symbol for current is I. P equal VI. Very important equation in this lesson. Very important equation. What is the unit of measuring power? Listen. What is the unit of measuring power? My unit of measuring power is watt. What? Watt. What's the symbol? Capital W. Unit of measuring power is what? Symbol, capital. Okay. In the tube, there is a box given. This ASUS part, cut it. In this box, I want you all to write these things. Put it to the mind and write. And don't just look and write. Don't waste the time. Once done, tell me done.
Done, sir.
Okay.
Done, sir.
Done, sir. Done, sir.
So why do I get
Done, sir.
sleepy when I try to study? These are the reason for feeling sleepy when you're studying. Number one, you're not hydrated. You're not drinking enough water. Number two, the light is dim. Try to have in your study place, try to have a good light source. Number three, for past 11 years, you're studying in that same place. Pattern is the same. When the pattern is same, automatically our body get adapted to that pattern, then it will try to avoid that pattern. Our body avoiding a pattern means making you feel sleepy. Maybe you change your table, at least your tablecloth you change. Some of you, your tablecloth is 11 years old. From grade 1, you are using the same tablecloth. Right? So make some changes, right? Small changes. Maybe change your bed into the other side, put the study table to the other side. If you can, don't keep the bed and the study table nearby. Big problem. Some fellows will study on the bed. Ekadam patta upset. Don't study on the bed. Surely you will feel the sleepy feeling. Passe, when you wanted to sleep also, you don't feel sleepy. Both the sides it will hit. Bed is for sleeping, the table is for studying. In the change the patterns of studying, right? You don't need to always study in your room. Staying in the room and doing the same thing again and again. Maybe you can study in the garden one day. In the garden, you can, if you have a garden, you can study in the garden or the balcony one day. In the hall one day. Of course, get the support of your family members. Now your family should know you're doing your first public exam, scholarship, first public exam. They should also support you when you're studying. If they put the TV louder, so tell them I need to study, and then ask the hall space if you want a change. Ask the hall space. After getting the hall space, you don't start using your phone. Get the hall space, then study in the hall. Make small changes, right? And of course, sleep. At least you need a 6 hours of sleep. Proper sleep. Nattang 8 hour. Proper sleep, eh? I can name 3 hour, you break it into 3 hour. That's not the correct thing. Properly 6 hours sleep. Continue. Okay. Hurry. So that's the equation. Power equal voltage into current. P equal VI. It is what? We'll solve some problems. Questions. Example question 1. Calculate. I'll first do this. You all don't go to do. First see how I do. Calculate power of a bulb working at 12 volt with a current flow of 2 ampere. 12 volt, 2 ampere. 12 volt voltage is given. Current is given 2 ampere. They are asking the power. Nothing big, no lamai. Power is equal to voltage into current. Voltage is 12 volt. Current is 2 ampere. Do the math there. 12 into 2 is 24. What? That's the answer. Huh? In the tute itself, solve the first question and the second question. Work.
Done, sir.
Done, sir.
Okay.
Done, sir.
Done, sir.
Okay.
Done, sir.
Solve the second question as well.
Sir, I don't.
Done, sir.
Done, sir.
Right. Example 2. Calculate the power of a oven operating at 230 volt. Voltage is given 230. With a 2 ampere current. Voltage 230, current 2 ampere. Voltage 230, current 2 ampere. I'll solve it here itself. There go the second one. Voltage is 230 volt. Current is 2 ampere. Now, if it's the MCQ question, of course, by looking itself, you can tell the answer. Tell me what's the power. One shot, tell me.
460. 460.
460.
Solving this for essay and structured essay type question. Power equal voltage into current. Write the equation. Voltage is 230 volt multiplied by current is 2 ampere. That is 460 watt. Capital W. Don't make mistake. 460 watt. That's it. That's about the power. Voltage into current VI. Okay. Right. Power is done. Power is done. Next, going to energy. Energy in an electric appliance. Energy in an electric appliance. Listen very, very carefully. Energy in an electric appliance. Right. How to calculate the energy in an electric appliance? Very simple. There's an equation to calculate energy of an electric appliance. What's the equation to calculate energy of an electric appliance? Very simple. Energy is equal to, there you go, power into time. Energy equal power into time. If I symbolically write it, energy E is equal to power P time T. Energy equal PT. Energy equal PT. Open the mouth and tell what's the equation. Energy E equal PT. Again, E equal PT. I can take this one more step ahead. Energy E is equal to, tell me what's the equation for power. Already we did it.
Voltage into current.
Voltage into current. Power is voltage into current. That means
Yeah.
instead of power, I can write voltage into current. Instead of power, I can write voltage into current. Time will remain as it is. So second equation for energy is energy E is equal to VIT. So two equation for energy of electric appliance, E equal PT. If I take it one more step ahead, E equal VI. Both correct? No. No, never. Yes, both are correct. Right? You can see, energy E equal PT. P is VI. Then energy equal VIT. So two equation for the same physical quantity. Again, louder, open the mouth and tell what are the two equations to calculate energy? E equal PT. E equal VIT. What's the unit? You all know what's the unit used to measure energy?
Joules.
Joule.
Unit is joules. Okay. Go to the energy part. Electric energy consumed by electric appliance. In that a box is given lamai. I want you all to write this in that box. Nicely write it. While writing, put the things into the mind. Don't wander up and down while you are writing. Keep your mind under your control.
Sir, what about the fundamental unit?
You all can make the fundamental unit. Fundamental unit of energy, you can make kg m squared s to the power minus 2. Fundamental unit of power also, you can make it. You can make it using this. Make the fundamental unit for potential energy. Potential energy is mgh, no? From there, you get the fundamental unit of potential energy. So any energy will have the fundamental unit. No? So here also you'll have the same fundamental unit. Power also you can get it by the basic equation. Power equation is work done over time. You make the unit for work done, and from there you can get the unit. That's the same. This.
Done, sir.
Okay.
Done.
Done, sir.
Done, sir.
Okay. We'll go to YouTube a little bit as well. Morning there was a complaint. Sir, you're not checking the YouTube messages. On YouTube babala. So can you tell a trick how to study chemistry easily? Each lesson depends, Puta. I of course have told tricks for some chemistry thing. Memorizing part, mostly I tell tricks. When I'm teaching that specific chemistry section, I teach the trick. Most of my students know. My trick is mainly based on ABCD. Alphabet order, so many tricks are made. So in physics, get marks for steps. There was a question. Yes, of course. Or in either. We'll solve some questions. Example question 1, I will solve. Remaining you are going to solve. Power of the headlight of a motor car is 50 watt. Headlight in the motor car 50 watt. Find the energy consumed when lamp is operated for 20 seconds. Power 50 watt, time 20 seconds. Question 1, power 50 watt, time 20 seconds. They are asking the energy. Energy E equal, y'all tell me which equation you are going to use. E equal PT, first equation or second equation? Looking at this data, tell me.
First equation.
Right. Even though we have two equations, depending on the question, you select the equation. Now here you can't apply VIT. Why? Voltage current is not given. Then you need to use PT equation. Okay. So energy equal PT. Apply the equation first. Always physics question, write the equation and write down. If unless and otherwise, it's an MCQ question. Energy E is equal to power 50 watt. Please write down the unit multiplied by time 20 seconds. Keep in mind, time should be in seconds, not in minutes, not in hours, or not in days or years or anything. Time in seconds. Now do the math. 15 to 20. That is 1000 joules. Energy is 1000. Simple question. Simple section actually. This lesson not at all hard. Surely a place where you can score if you can remember equations. That's why one shot put the equation to the mind when you are writing it, sir. Do the first question and you all do second and the third both. You all do second and the third. Be careful. Time should be in seconds. No calculators. No calculators. Train your brain. No point using a calculator. Remember, no calculators. No point doing the question first unless and otherwise it's done using your brain. I'll put the Tutan key. Maybe I'll change Shani, that's easy.
Done, sir.
Okay.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Work finish off.
Done, sir. I just saw option in Zoom. While screen sharing, we can shift the screen. I'll just check whether it works. I just saw option in Zoom. While screen sharing, we can shift the screen. I'll just check whether it works. No, neither. Not YouTube people. Hurry. Hurry. Right. Question two. Question two. I hope all of you have done it. An electric motor operating with a power 200 watt. Power is given. Operate for 2 hours. Time is given in hours. Calculate the energy consumed. Power 200 watt. Time is 2 hours. Can you do the question using hours? No. You need to convert it into what? Seconds. Y'all tell me using your maths knowledge. 1 hour equal how many seconds?
3,600.
3,600 seconds. How? 1 hour consists 60 minutes, 60 minutes.
60
1
into
minute
60.
consists 60 seconds. 60 into 60, 3,600. Lamai 1 hour, 3,600 seconds. Ehenang 2 hours, how many
7,200.
seconds?
7,200, sir.
1,200.
1,200, sir.
Tell me, first equation or second equation you are going to apply?
First.
And hurry. E equal PT. Most of the question you can solve using E equal PT equation. Power 200 watt. Time 7200 seconds. No calculators. Slowly solve it. 72 into 2. That is 144. 1, 2, 3, 4. 4 zeros.
14 lakh 40,000.
4 joules. Big number. No? Tell me this in kilojoules.
140 kilojoules.
And you divide by 1000. Always
Yes.
remember something to convert into kilo part of it, you divide by 1000. Something to convert into kilo part of it, you divide by 1000. Gram to kilogram, you divide by 1000. Joules to kilojoule, you divide by 1000. When you divide by 1000, 3 zeros will cancel off. When 3 zeros cancel off, 1440 kilojoules. I keep it in both the way. That's because in case in the exam, if they tell you to keep it in kilojoule, you need to keep it in kilojoule. Otherwise, not needed. But of course, this is a big number. 1,440,000 joules can a big number. So better to keep it in kilojoules. Both the way you can keep it. Because in the question, they are not telling which unit you need to keep it. Harine? Perfect. Last question. Question 3. Last question, right? Question 3. A fan operates at a voltage 230 volt with a current 2 ampere. Voltage is given, current is given. Question A, calculate the power. They are asking the power. Right. Question 3, voltage is 230 volt.
460 volts.
Current is 2 ampere. A, they are asking power. Power is equal to VI. First equation. From there, voltage is 230 volt, current is 2 ampere. You do the math there. 460
volt.
What? You call it what? 460 watt. B part. Calculate the energy consumed in 1 hour. In 1 hour, how much of energy is consumed? 1 hour, how much of energy is consumed? First tell me, 1 hour, how many seconds?
3,600.
3,600.
3,600.
seconds. Energy equal, now you can use any equation. BIT also you can use, otherwise PT also you can use. Go for the easiest one. PT equation is easy, no? E equal PT. Otherwise, you can use VIT also. From there, power is 460 watt. Time is 3,600 seconds. Solve it, slowly multiply it. 46 into 36, 6, 27, 18, 1, 13. That is 6, 5, 6, 1, 1, 2, 3 zeros remaining. 1,656,000 joules. 1,656,000 joules. If I keep it in kilojoules, how much am I?
1,656 kilojoules.
Divide by 1,000. 1,656 kilojoules. Big values, you can keep it in kilojoules. So it's easy. Hurry. Simple question, but maths is there. If you are good at maths, guaranteed place where you can score. That's it. Power done. Energy done. One more time will remind. Tell me. Power. P equal
VI.
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 Energy. Two equations are there. E equal first equation.
ET.
PT. Second equation. E
EIT.
equal
VIT.
That's it. Next. Commercial unit of measuring electric energy. What's the commercial unit of measuring electric energy? Listen very carefully now. What's the commercial unit of measuring electric energy? First of all, what does this commercial unit means? The moment you see the word commercial, that means something related to money. The moment you see the word commercial, that is something related to money. Commercial unit of measuring electric energy. What does this mean? To our houses, or if you have a certain business, electricity is given, electric energy is given. But every month you get a bill. You have to pay for the electric energy you are using. Using what unit they measure the electric energy you are using? Using what unit they convert it into money based? Every month you pay an electricity bill. No? How that conversion is done? How do they measure electricity, electric energy in your domestic electric consumption? Monthly you get a bill. How that electricity is measured, using what unit they measure? Now you'll tell answer, we can measure it using joules. Lama, using joules we can measure, no problem. But think, you get a monthly bill, no? Do we get day bill? No. We get monthly bill. For a month, amount of electric energy you are using, if you try to give it in joules, that will give a big value, no? Just think, for a month electric energy you are using. Now, here we calculated the electric energy used in a motor car. I can remember, in a motor car. This one is motor car. Motor car, I think the headlight question, I guess. That is headlight question. Where? Yeah, headlight of a motor car. Headlight of a motor car itself, that is working for 20 seconds. That is working for 20 seconds. You are getting this value. Now think, how many bulbs in your house? How many electric devices? Iron, oven, fan, fridge. So many electric devices are there. How long you use it? Bill is made for a month. Can you measure and write the electric energy consumed for a month in joules? You can, but the value is very, very big. Very big. It will come in millions and billions if you write it in joules. Just imagine that uncle. What uncle? The uncle who comes to write your electricity bill. Let's take he is measuring the electricity in joules. This is the value you are getting. This is the amount of electric energy you have used for that month in joules. That uncle, with how much problems he comes, family problem. He comes at about 10 o'clock, 11 o'clock. No, it's very sunny. He comes while writing the bill. If we make a mistake in one single zero, your full bill will turn upside down. It might be a difference between million and billion. 1 0. 1,000 can become 10,000. 10,000 become 1,000. If we make a mistake in 1 0, full bill will turn upside down. So y'all tell me, is it standard to measure electric energy in joules when it comes to commercial purpose? Is it standard? Especially in a country like Sri Lanka. Yes or no?
No.
No, sir, no.
I agree. SI unit of electric energy is joules, but this is not
No, no,
correct.
no, no.
We can understand it. Errors are high because the value is very big. As the value is big, as the errors are high, they have made another unit to measure, to commercially measure electric energy consumption. What's the commercial unit used to measure electric energy? Lamai, commercial unit of measuring electric energy is kilowatt hour. What is the commercial unit of measuring electric energy? Kilowatt hour. If I write it symbolically, K W H. Simple K, capital W, simple H.
land phone is called
KWH. You lamai, mute yourself. What's the commercial unit of measuring electric energy? kWh, kilowatt hour. That's the commercial unit of measuring electric energy. Okay. Question. Kilowatt hour. It is a unit for energy or power. Kilowatt hour. It's a unit of energy or power.
Energy.
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 Power.
Energy or power.
So
Energy.
both are same, no?
Energy.
Energy.
For energy and power. For both, sir.
Energy, sir. Energy.
We'll check the YouTube comments first. It's a
So
unit for
energy and
energy.
power.
I'm gonna tell the opposite. Power.
Energy.
Time.
Both.
So energy and power both.
Today people also saying. Mixed answers are coming. Ane puti.
Energy.
Kilowatt hour. Read the heading. Read the heading. Commercial unit of measuring electric. Tell me. Electric.
Energy.
Energy.
Heading is electric energy. How can it be power? So kilowatt hour. Remember, it's the unit for energy, not power. Remember, listen. Now, what's the difference between power and energy? Remember, power is for the device. Device have the power. Energy is the consumption. Those are two different things. Power is for the device. Energy is the consumption. Now, for example, if you take your phone charger, in your phone charger, they will have written how much is the power. You take your fan, go behind the fan and see there will be a sticker. How much is the power of that fan? 16,000 watt, 20,000 watt. Your iron box, there is a certain power for that. 20,000 watt, 30,000 watt. So that power is for the device. Energy is for the consumption. Energy means how much you are consuming. They check the consumption or they check the device. And will that bill person come and ask you, how many fans are there in your house? How many lights are there? How many bulbs are there? Will you ask that and write the bill? Or he will check the consumption and write the bill?
We will check the consumption.
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 He won't come and ask, no, how many fans are there? What fan you are using? I am also a fan of you. He won't ask. He will ask, what is the consumption? consumption only the bill is made. Remember, consumption is energy. What we consume is energy. Power you can't consume. You can't look at the equation for power. Power is equal to voltage into current. Voltage and current is for the device. You give this voltage, you supply this current, it will work. Otherwise, it won't work. So voltage and current, that is power. Power is for the device. Look at energy. Energy is equal to power into time. How long you are using that device? The more you use it, the more consumption. Device is there. Device is defined by the power. How long you are using that? The more you use it, the more consumption. The more energy you are using. The more energy you use, your bill will be high. Okay, put that in the minus assumption. 99% of the students, even though you have done this lesson in your school or whatever places you have done, you don't know the difference between power and energy. Power is for the device. Energy is the consumption. Energy comes with time. The more time you use, the more consumption it is. Power is voltage into current. You supply this voltage, you give this current, it will work. Otherwise, it won't work. Any device in your house, today go and check in that label. They will mention the power there. So power is for the device. Energy is for the consumption. Energy is consumption. So your bill is made for the consumption, not for the device. Whatever the device you have, they don't care. But how much it is consuming, that is what they care. That is why they tell you to switch off the lights if they are unnecessarily on. Why? When you switch off the light when it is unnecessarily on, you are reducing the time. When you reduce the time, energy you are reducing. When you reduce the energy, your bill will reduce. Can you define that using VI equation? Benny? You can't define that. Consumption is based on time. Remember, your bill is made based on how much of electric energy you are using. So kilowatt hour is a unit used to measure energy, not power. Put that to the mind. Not power, it's a unit used to measure energy. They can ask this separately as a question, MCQ question. Which of the following is a unit used to measure energy? They can ask. Kilowatt hour, it's a unit used to measure energy. Now I know some fellows will be asking, sir, kilowatt is power. This is power. No. I agree with your argument. Kilowatt is power. What is what? What is power? Kilo kiyanne lamai a big value. Kilo kiyanne 1000. Kilo means 1000. So kilowatt is power. I agree with that. Kilowatt is unit used to measure power. You multiply by R. R is what? Time. Tell me, what is PT?
Energy.
Energy. So kilowatt hour is a unit used to measure not power. Take your bill and see today. Electricity bill. Those things you need to check in your houses. You need to know how much you are using. How much you are financially, how much you are contributing to your house. Those things you should know. Now you all are matured enough. Till you all are not kids. You should know how much is the bill coming. How much you can save. Those things you need to know. You should contribute for the financial growth of your family now. You're big now. Take your electricity bill. Some fellows doesn't know that what is the electricity bill. How much you are getting. You should know those things. Even girls. Girls are not out of the box now. All are same. Take your electricity bill and see. In your electricity bill, that uncle will mention something as 80 units, 90 units, 100 units. Have you all seen that?
Yes.
Yes, sir.
Yes, sir.
What is that
Yes,
80 unit, 90 unit, 100 unit means? Remember, 1 kilowatt hour kiyanne 1 unit there. So in your electricity bill, if they mention 80 unit, that means what? 80 kilowatt. So you have used 80 kilowatt hour of electric energy during that month. If your bill is mentioning 90 unit, how many kilowatt hour?
90 kilowatt-hour.
90 kilowatt hour. They won't mention it in joules. They just put unit kiyanne kilowatt hour. 100 kilo. Usually 100 unit means bill will almost double. Below 80 kiyanne bill is very low. Once when you pass 90, bill will be double. There is a calculation part, right? My mother scolds. Hey, once when it hits 100, she will scold, and only again when we are in grade 6, grade 7, again she'll scold us because of your only it has gone at 100 units. Usually our bill we try to keep it between 80 again during our school days. If it touches 100, finish. House will turn upside down. Maybe grade 6, grade 7 now, eh? Now mother doesn't know what's the bill. Mother, no, I handle all those things. 1 unit is what? 1 kilowatt. So that's how they do the conversion. That's how they do the conversion. Hari? So that is commercial unit of measuring electric energy. Okay. Go to the tutorial. Still not done. So many things are there. More to talk under this kilowatt hour section. We'll just read the first part. Measuring electric energy in kilowatt hour. Commercial unit of measuring electric energy. Electric energy is measured in kilowatt hours by the domestic electricity meter, our meter box. It measures the electric energy in kilowatt hour. Please underline or highlight it. Please underline or highlight. Oh, no need to write anything. Just underline or highlight. Hurry. Now listen, this kilowatt hour, we can talk a big about it. Now listen. What does 1 kilowatt hour means? What is the meaning of 1 kilowatt hour? Listen, first listen, I will tell the definition, then I will explain. What does 1 kilowatt hour means? Meaning of 1 kilowatt hour. Right. Let's take, you have an electric device. The power of the electric device is 1 kilowatt. I already told you, power is for the device. Power of the electric device is 1 kilowatt. What does this 1 kilowatt hour mean? The amount of electric energy I am supplying to this 1 kilowatt power device for a time period of 1 hour. That is 1 kilowatt. Again, what is 1 kilowatt hour means? You have a device of power 1 kilowatt. You supply electric energy for how long? 1 hour. The amount of electric energy you are supplying is 1 kilowatt. Again, one more time, listen. You have a device. Let's say you have a fan. This is a fan. Power of the fan is 1 kilowatt. It is working for 1 hour. So for that, you need to give energy, no electric energy you need to give, no? How much you are giving is 1 kilowatt. So what does 1 kilowatt hour mean? A device of power 1 kilowatt working for 1 hour consumes the energy of 1 kilowatt hour. Okay. 1 kilowatt hour is the amount of electrical energy consumed during 1 hour by an electric appliance with a power of 1 kilowatt. 1 kilowatt, 1 hour working, energy is 1 kilowatt hour. Okay. Right. Now we have a calculation. Now we have calculation. Look at the board. I told you this kilowatt hour, we can talk very deeply about it. Now we have calculation. How to calculate energy consumed in kilowatt hour. How to calculate energy consumed in kilowatt hour? There's an equation. Energy consumed in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours. What is the equation to calculate energy consumed in kilowatt hour? Energy consumed in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours. That means, for example, let's take there is a device. Power of that device is 2000 watt. It is working for a time of 3 hours. What is the energy consumed in kilowatt hour? Very simple, very simple. Look at the board. Energy in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours. What is the power in watt? Onna puthe 2000 watt. Power is 2000 watt. You divide by 1000 multiplied by number of hours. How many hours it is working? 3 hours.
3,000.
Don't go to convert it into second. Kilowatt hour, you can keep it in hours. So when you do the math there, 1230, 1230 cancel off. 2 into 3 is 6 kilowatt. That's the energy in kilowatt. Again, look at the board. Again, look at the board. How to calculate the energy consumed in kilowatt hour? Energy consumed in kilowatt hour is equal to, repeat with me, power in watt divide by 1000 multiplied by number of hours. Again, power in watt divide by 1000 multiplied by number of hours. In the tute, first box, this first box, I want you all to write.
Done, sir.
Answer.
Okay. Put the things to the mind. I told you don't keep this to study separately. Okay. Keep the equation in mind. We'll solve question. But before that, a small relationship I wanted to teach you all. Look very carefully. Listen, big mathematical part, you miss a single step, you'll go out of the this thing, out of the section. So listen very carefully. Right. Now see, you all tell me what's the commercial unit of measuring electric energy?
Kilowatt-hour.
Kilowatt-hours.
Commercial unit is kilowatt hour.
Hours.
What is the SI unit of measuring electric energy?
Joules.
SI unit is joules. My question is, what's the relationship between kilowatt hour and joules? It should have a relationship. This is also a unit used to measure energy, electric energy. This is also a unit used to measure electric energy. There should be a relationship between kilowatt hour and joules. What's the relationship between kilowatt hour and joules? Listen very carefully. I will tell 1 kilowatt hour equals how much of joules? I'll tell 1 kilowatt hour equal how much of joules? Right. Right. Listen very carefully. Yeah? How am I going to solve this? Right. Now, y'all tell me, what's the equation for energy?
E equals PD.
Equal PD. Now, you all tell me, what's the SI unit of joules? What's the SI unit of energy?
Joules.
Me. Joules. Sorry. What's the SI unit of power?
Watt.
Watt. What's the SI unit of time?
Seconds.
Then I can tell my joules is equal to what second? Agree?
Yes.
Yes.
SI unit of energy is joules. SI unit of power is watt. SI unit of time is second. Then joules should be equal to what second? Joules equal what second? Right. Keeping that in mind. What is our aim? What are we going to do? We are going to convert kilowatt hour, 1 kilowatt hour into joules. That is our aim. Leave joules part aside. Forget about joules. I will first convert kilowatt hour into watt second. First, I'll convert kilowatt hour into watt second. And I already know watt second is what? Joules.
Joules.
Then if I know watt second, then I can write it in joules. If I know watt second, then I can write it in joules. So first I am going to convert kilowatt hour into watt second. Then I am going to write it in joules. That's how I'm going to find the relationship between kilowatt hour and joules. That is my methodology. Eh? First understand the methodology I'm going to use. Kilowatt hour into watt second, then watt second into joules. Right. We'll do the conversion slowly. Listen, eh? These are interesting mathematical things. Listen. How to convert kilowatt hour into watt second? Two things I need to do. Now, first look very carefully. Look at kilowatt hour. First of all, I need to remove the kilo part. Okay. That's not enough. Another one I need to do. I need to convert hours into second. If I do both these changes, this will become watt second. Agree?
Yes.
First, I need to remove kilo part. Then I need to convert hours into second. If I do both these things, it will become watt second. We'll slowly do this conversion then. Be in the world. Right. First, I will remove the kilo part. You all tell me, kilo means what?
1,000. 1,000.
Thousand.
Kilo means 1,000. Remember this. 1 kilogram is 1,000 grams. What does this mean? Kilo kiyanne lamai 1,000. That's the meaning. Kilo means 1,000. So kilo means 1,000. So instead of kilo, what can I write?
1,000.
So I'm going to remove kilo and write 1,000 there. 1 into 1000. 1 into 1000. Kilo is now removed. What is remaining? R is remaining. Understood the first step?
Yes, sir. Yes, sir.
Yes.
I removed the kilo part. Kilo is 1000. So 1 into 1000 watt R. That's not enough. Another conversion is remaining. Hours should be changed to seconds. Y'all tell me 1 hour. How many seconds?
3,600 seconds.
3006.
3600 seconds. A කියන්නේ ළමයි instead of R I can write 3600 seconds. I'll write it and show 1 into 1000. What will remain instead of R? What can I write?
3,600 seconds.
3060.
100. Understood that step? Nothing big. I converted R into second. Now clumsy, write it nicely. 1 into 1000 is 1000. 1000 into 3600. That is 3, 600. Another 000. 1 into 1000 is 1000. 1000 into 3600 is 3,600,000. What are the units remaining? What
What?
is remaining? What else? Second
Second.
is.
Second.
Now you all tell me. What second is what?
Joules.
Joules.
Louder.
Joule.
Joules.
This side 1 kilowatt hour is remaining. What second is what? What second
Joule.
is joules. That
Joules.
means instead of what second? What can I write?
Joules. Joules. Joules.
You are write it scientifically using scientific notation. 1 kilowatt hour is scientific notation 3.6. 1, 2, 3, 4, 5, 6 into 10 to the power
10
6.
to the power 6. Joule.
So what's the relationship between 1 kilowatt hour and joules? 1 kilowatt hour is 3,600,000 joules, or in scientific notation, 3.6 into 10 to the power 6. Understood the conversion? I think in the textbook, this is given directly, as if it came from the heaven. I told you the correct conversion, how this is coming. And there is no point studying this. Again, see, nothing big. Energy equal PT. SI unit of energy is joules. SI unit of power is what? SI unit of time is second. 1 kilowatt hour. First I'm going to convert to watt second. Then I need to remove kilo. I add 1000. I need to convert hours into second. Instead of R, I write 3600. Multiply 3,600,000 watt second. Watt second is joules. So 3,600,000 joules. Sorry, 3,600,000. That is 3.6 into 10 to the power 6 joules. That is 1 kilowatt. Okay. No? Now what is needed here is I have given this small box to write down only this. But this part. 1 kilowatt hour is 3,600,000 joules. Only that part to write there. But it's better to write the full conversion. So maybe by the side to write the full conversion and keep, but in that box, this box, this part should go. This part you write separately and keep. Quickly work. YouTube, right? So I'm having a big coverage problem because of heavy rain. No problem. My YouTube video will remain. Okay.
Okay, sir.
Okay, sir.
Okay, sir.
Thank you.
Done, sir.
Done, sir.
Huh. This solve some problems. Question A. Calculate the energy consumed in kilowatt hour. Kilowatt hour, eh? When a bulb of power 100 watt works for 3 hours. 100 watt works for 3 hours. I'll do that question. Second one onwards, you're going to work, eh? 100 watt working for 3 hours. Right. Question 1. Power 100 watt time 3 hours. They're asking the energy in kilowatt hour. Apply the equation energy in kilowatt hour is equal to power in watt divide by 1000 multiplied by number of hours. I wrote it in short form. Power in watt is 100 watt. Divide by 1000 multiplied by number of hours 3 hours. Do the math. 1, 2, 0, 2, 0 cancel out. 3 divided by 10. How much?
0.3.
0.3 kilowatt hour. Okay. Do the first one and the second one. First do the second one and send me the answer. We'll discuss that. Then we'll go to the third one. I'll display the question. So the first one, then do the second one, send me the answer. Then after the discussion, we'll go to the third one. Work. Online people can't see this one. No? Right. YouTube people. First write this. First question. Remember kilowatt hour K simple, W capital, H simple again. Right, I'll display the question for the second question. Second one done. Send me the answer. Perfect. Hurry, I'll discuss the second one. Calculate the energy consumed in kilowatt hour when 3 bulbs of power 100 watt. Each works for 3 hours. 3 bulbs, each is 100 watt, works for 3 hours. Question 2. There are 3 bulbs, each 100 watt. I mean, 1 is 100 watt. Ehenang, y'all tell me 3.
300 watt.
1 is 100 watt, nang 3. How much? How much?
300 watt.
300
300
watt.
watt.
Nahari, 300 watt.
300.
Working for how many hours? They told 3 hours. Neither.
3 hours.
Yeah.
See, now 1 is 100 watt, 3 is 300 watt. Energy in kilowatt hour equal power in watt divided by 1000 multiplied by number of. Power in watt is 300 watt divided by 1000 multiplied by number of hours is 3 hours. 1, 2, 0, 2, 0 cancel off. 3 into 3, 9. 9 divided by 10 is 0.9 kilowatt. Do the third one. Some people are wondering, how did I get 300? 1 bulb, 100 watt. 3 bulb, 300 watt. Can you explain the second question once more? 1 bulb is 100 watt. Then 3 bulbs are there, 300 watt. They are working for 3 hours. 300 watt, 3 hours. Do the math. If you want, you can separately calculate. 100 watt working for 3 hours. Second 100 watt working for 3 hours. Third bulb 100 watt working for 3 hours. Without a 0.3, 0.3, 0.3, you then get 0.9. That way also you can. Third question take 1 month equals 30 days. That's how we usually do questions. 1 month is 30 days. Do send me the answer for the third one. Think and do one. Third one you can't do while doing something else. Third one, focus, listen, properly do.
So can you please upload the tube on the screen?
So can we put 0.9 unit? No, don't write the word unit. Properly write what's the unit there. Hurry. Enough time. Read the question first. If 4 bulbs each having a power of 100 watt. 4 bulbs are there. Each is 100 watt. 4 bulbs each is 100 watt. Are used for 3 hours. And 5 bulbs each with a power of 60 watt are used for 4 hours daily. This is for 1 day. Find the electricity consumption during a month. I'll first write the data, required data. See now. If 4 bulbs are there, each having a power of 100 watt. Each having a power of 100 watt. 100 watt. How many bulbs are there? 4 bulbs. Ehenang, y'all tell me what's the total power.
400 watts.
400.
Now this is working for how long it seems? It is working for 3 hours daily. Data is given for a day. Time is 3 hours.
3 into 30.
And that's about 100 watt power bulb. Another set is also there. What is that set? 5 bulbs each with a power of 60 watt. 60 watt bulb is there. How many bulbs are there? 5 bulbs. එතකොට ළමයි, what's the total power?
300 watts.
300 watt. Now this set is working for how long it seems? I use for 4 hours daily. Per day data is given. 4 hours daily. What are they asking? They are asking the electricity consumption during a month. Leave the month story aside. Fully leave the month story aside. First, we will find how much of electricity is consumed for 1 day. Then we can find for a month. First, we will find the electricity consumption for a day. Then we can deal about the month. Then we can go to the month. So leave the month aside. We'll deal the day part first. For a day. In a day, this set of bulb is working for 3 hours. We can find the energy consumed. I'll write it as E1. E1 is equal to power in watt divided by 1000 multiplied by number of hours. E1 is power in watt is 400 watt multiplied by 1000, divide by 1000 multiplied by 3 hours. From there, E1 is 0000 cancel off. 4 into 3 is 12. 12 divided by 10 is 1.2 kilowatt hour. That is for this set of bulb. Not done. We have another set of bulb. We'll find the electric energy consumed there. I name it as E2. E2 is power in watt divided by 1000 multiplied by number of hours. Power in watt is 300 watt divided by 1000 multiplied by number of hours, 4 hours. From there, do the math. E2 is cancel the zeros. 0000 cancel off. 3 into 4, 12. 12 divided by 10 is again 1.2 kilowatt. That is for this set of bulb. This is for this set of bulb. This is for this set of bulb. And this is for a day. First, we will find what's the total electric energy consumed for a day. Per day. Per day. How much is the total electric consumption per day? I'll write it. Total electric consumption per day. Total electric consumption per day is this set plus this set. That is E1 plus E. What is the E1 value there? E1 is 1.2 kilowatt hour. E2 is 1.2 kilowatt hour. So if I write it there, 1.2 kilowatt hour plus 1.2 kilowatt hour. When you add it, you can get the electric consumption for a day. How much? 2.4 kilowatt hour. This is for a day. They are not asking for a day. They are asking for a month. Total electric consumption per month. Per month. What you do? For a day, lamai 2.4. For a day, 2.4. Ehenang, for a month, how much? Multiply by
30.
30.
2.4 multiplied by 30.
72.
72 kilowatt hour is the total electric consumption for a. Again,
Yes,
see
sir.
how did I do this question? Again, see how did I do this question? Listen, 100 watt, 4 bulbs are there. Then totally 400 watt. Working for 3 hours. From there, I found the electric energy consumption by this set of bulb for a day. 60 watt, 5 bulbs are there. Then total power 300 watt. Working for 4 hours. From that, I calculated the total energy consumption again for a day. This is for this set of bulb. This is for this set of bulb. When you add it, you get the total energy consumption for 1 day. They're not asking for a day. They're asking for a month. So this value you multiply by 30. From there, you can get for it. Another method is there to do the same question. Different methods you can use. Another method you can do like this also. Here itself you can multiply by 30. Here itself you can multiply by 30. Those two you can add. We calculated for a day, added it, then we multiply by 30. You can do here you multiply by 30, here you multiply by 30. Those two you can add. Directly you can get for a month. That way you can do. Now some people will suggest a method like this. Answer. Add both the powers together. Very good. 700 watt maru. Add both the time also together. Maru. 7 hours.
So we could
700
multiply
watt is
the
there,
time
7 hours
by
is there.
24.
From there you get the value. Then you multiply by 30. Hema, can you get the answer? Can you get the answer that way? No, you can't. First of all, tell me, now what is this story telling us? What is this 400 watt? What is this telling us? There is a bulb. There are 4 bulbs, 100 watt. Think about our serial bulb set. 100 watt, 4 bulbs are there. All those 4 are working for 3 hours. They are working for 3 hours and then they go off in a day. 4 bulbs, each is 100 watt, working for 3 hours and then they go off. Another set is there 60 watt. 60 watt, there are 5 bulbs. It is separately working for 4 hours and then they go off. Is there any bulb working for 7 hours? Is there any
No.
bulb working for 7 hours here? No. So can you add it and take 7 hours here? No, you can't. Nothing is working for 7 hours. At least power you can add. Power is for the device and you can add and take. Can you add the time and tell? If you tell 7 hours, that means you are trying to tell this is working for 7 hours, this is working for 7 hours. Hima, can you tell the question? No, you can't say the question that way. This is separately bulb is there, working for 3 hours. This is separately bulb is there, working for 4 hours. Then you separately find the energy consumption. Then you add it. Then you add it. That's how you do the question. Okay. So that's the method. A reason maybe you would have not got the correct answer. Check your calculation. From somewhere you miss at least 0, your calculation will go wrong. That's the second reason for getting wrong. Those are the 2 main reasons. So you can't add and do it. One shot you can't add and do it. You can't tell 7 hours. Nothing is working for 7 hours here. So I multiply 3 hours into 30 days and simplify it. You're doing it that way. 3 hours into 30 days. Here itself you multiply by 30. This one you multiply by 30. 1.2 into 3 is 2.4, 3.6. 1.2, 3.6. 3.6 kilowatt hour. Here also you multiply by 30. Then you multiply this by 30. Again 3.6 kilowatt hour. 30 ne dambo 36. One decimal wrong and full answer will go wrong. You multiply by 30. Multiply by 30, you get 36 kilowatt hour, 36 kilowatt hour. 36 kilowatt hour plus 36 kilowatt hour, how much?
72.
You should get the answer. Anyway, you should get the answer. I did that way, right? without changing like 300 watt total, I can multiply just as 3. Yes, that's instead of 300 watt, just multiply by 3. Instead of 300 watt, just multiplying by 3. Danny. Instead of 300 watt, just you multiply by 5. That's correct. Marini. Any doubts until there? Maths part recheck. We go to the YouTube side also. Anybody with any doubt? There was a question in YouTube. So then 3,600,000 joules is equal to 1 unit. So then 3,600,000 joules is equal to 1 unit. Yes, 3,600,000 joules is 1 kilowatt hour. That is equal to 1 unit. Yes, correct, Putha. Good. Those are the doubts. Neither. Those are the doubts in YouTube. So our Sri Lankan per unit, what's the price? I don't know the price amount. It actually depends. Now, in maths, did you all learn how they calculate your tax? For your first 100,000 rupees, no tax. For the first 500,000, there's a certain amount of tax.
4%.
Then for 1 million, it will double and come. There's no correct range. For 1.5 million, again, it will double and come. Tax. So just like tax only, this also. For 80 unit, there is a normal value. After you pass 100 units, some doubling will happen. That part I know because I know when we analyze the bill, we can understand that. You can find it in internet, how much is for 1 unit. Or once when that uncle comes to put your bill, ask that, uncle, 1 unit is how much? Give him some water, money uncle. Giving some water, ask him, give me 1 unit is how much? He will tell all the story once when you talk like that. Okay then. Mainly calculation part I wanted to finish today. Calculation part is fully over. Again, redo all this question. Go through this equation. Tomorrow again same time, 7 o'clock to 9 o'clock. 7 to 9 we have the same session. Tomorrow fully our theory part is only there. Memorizing part. We'll have to learn about efficiency and then domestic electric supply. Then about each and every component in our electrical component in our house. So fully reading part is only there tomorrow. Before coming to the class, best is if you can go through the tute and come. Only reading part is there. Tomorrow full and full reading part. Right? So if you can go through the tute already and come, that's more better. Hari? And a calculation part today over. Again tonight, do all this question, put the equation to the mind, finish it off. And this lesson again, don't keep to study again. This lesson should be fully done. Now today half is done, tomorrow half. With that lesson done. That's how you study this lesson. The best is tomorrow. I told you, reading part is there. I already told you what we are going to do tomorrow. Reading part is there. You all read and come once. So when I am telling, maybe some doubtful things are there. When I am telling, those will be clarified. Okay. All right. Some fellows are already sending bye. Okay, then I'll finish. Enough for today. Tomorrow morning, grade 10 hydrostats is there. Those who want can join hydrostats also. Evening, as usual, tomorrow we have power and energy of electric appliance, second session. Okay. Okay, then. Until then, keep working. Bye.
Bye, sir. Good night,
Bye.
sir.
Good night, sir.
Thank you, sir.